Astronomers love to show pretty pictures. We show pretty pictures of galaxies, stars, planets, and we love to talk about what's in these pretty pictures. But some of the most exciting discoveries in astronomy are things we can't take a picture of, like what I'm going to talk about today, dark energy. The story of dark energy starts in the 1920s. Astronomers made a very startling discovery. They noticed that nearly every other galaxy was moving away from us. Not only that, galaxies that were further away were moving away faster. It was quickly realized that this picture is consistent with an expanding universe, where space itself is expanding. If I start two galaxies, one block of space apart, and this block of space is expanding, let's say it doubles every million years, over a million years, those two galaxies move one block of space apart. So they're moving at a velocity of one block of space per million years. Let's say two galaxies instead started 2 blocks of space apart. Well, in that million years, those 2 blocks of space double to 4 blocks of space. And those two galaxies see each other moving away at 2 blocks of space per million years. If they start at twice the distance, they see twice the velocity away. So our observations were consistent with an expanding universe. So this was sort of the status quo. Astronomers realized we lived in an expanding universe, and that's what we knew for 70 years. It took us that long to add to this picture. In 1998, 2 teams of astronomers looked at very distant galaxies, and they saw that based on how far away they weren't moving away as quickly as we would expect. Now we have to remember that in astronomy, when we look very far in distance, we're looking back very far in time. It takes time for light to get to us on Earth. So for these distant galaxies, we are seeing light from the universe when it was billions of years younger than it is now. So this observation that the galaxies weren't moving as quickly as we'd expect means actually that early in the universe wasn't expanding as quickly as it is now. That's a very exciting discovery. That means the universe is accelerating in its expansion. Now, if you remember just one equation from high school physics, you probably remember Newton's second law, F equals ma. To get A, an acceleration, you need a force. For something to be accelerating, something must be actively pushing on it. Something is actively pushing on the universe for it to be accelerating. Now, we can't take a pretty picture of it, but our knowledge of the most basic laws of physics say that something is throughout the universe pushing on it, something we call dark energy. Thank you.